in just a second. Okay, so now it's recording. So I won't be able to see the chat. So if you have a question, just like unmute yourself. No worries. No questions are stupid. But hopefully you can see my screen. So this week, tomorrow you're going to have 2 quizzes. So there's going to be one over AKS 8, which is that finite and infinite series summation. I'm going to go over that in just a second. And then one is going to be over AKS 27, which is that survey, experiment, and observation. All you're going to have to do is basically just identify which one it is. Is it a survey, experiment, or observation? Again, these quizzes really shouldn't take you more than maybe 10 minutes to do each. So hopefully tomorrow is a real light load. If you missed last week's test, so the week before spring break, it's going to be open tomorrow. It's going to be open all the way up until like 11:59 p.m. Okay, so you can take it anytime during the day. Just make sure you do both or all 3 sections. Midterm is coming out tomorrow. You're going to have 1 week to complete it, and it's just going to be, basically it's going to be helping your grade. So it's going to be over previous AKS, and we're going to be able to replace grades based off of that. So please make sure that you take care of that as quickly as you can so that we can help your grade, help you, you know. An extra credit project came out. Your proposal or planning process is due April 17th, and your final project is due May 8th. Don't overthink this project. It's not supposed to be super extravagant. You don't have to like go out and buy stuff. It can be something around your house. Like, I think I was talking to somebody earlier today. I was like, you know, chores. You vacuum, you clean the bathroom. Well, how long does that take you? Well, I want to find out how long it's going to take me to clean the house so that I can go play basketball or I could go for a run. And so I could create an equation based off of that. That would be AKS 16 and 17. So are there any questions on these so far or logistics? And again, I can't see the chat, so you're going to have to unmute yourself if you have a question. So everybody should be okay on these? Okay. So basically what I'm going to go over today is I'm going to go over AKS 8, and then I'm going to go over AKS 27. Somebody did ask me to go over one other thing, and I'll do that a little bit later. But stop me if you have any questions, okay? So AKS 8 is finite and infinite series. So finite is that it has a starting and ending term. Mr. Jones brought up the term diverges. That's just basically a fancy term for finite, okay? So it's diverging to a specific point. The formula that you're going to use is that S sub n equals a sub 1 times 1 minus r to the n power divided by 1 minus r, okay? And so that's when you have a starting term and an ending term. Infinite means that it goes on forever or goes to infinity. The fancy term for this is converges. And the formula we use for that is a sub 1 over 1 minus r. Okay? So, for example, for finite, if I had 1 plus 3 plus some other numbers in between plus 81, the starting term in this instance is 1. So that would be my a sub 1. The ending term is 81. That tells us that we have a finite series. Okay, the fact that it stops at a certain number means that we have a finite series. So that means that I can find the sum of these, which means that I'm going to add them all up, right? That's what sum means, using the finite formula. Okay, so let's say, for instance, I wanted to find the sum of 5 terms of this series. Okay, I would plug into this formula right here. Okay, so a sub 1 we've already identified as 1. That's our first term. So that's going to be 1 times 1 minus. In this instance, this example should have given a couple more numbers in between, but that's okay. I'm telling you that the r is 3 in this instance, but normally they would say, you know, a series is this, and you would see that from this number to this number, it's a multiplication of 3. From 3 to 9, it's a multiplication of 3. Another way to do this is to take the second term and divide it by the first term. So this will be 1 minus 3, and we'll raise it to the 5th power because we're trying to find the sum of the first 5 terms. So we'll raise it to the 5th power, and then we'll put that over 1 minus 3, which was our r. Okay, and then we would plug this into our calculator, and it would give us a number. Are there any questions on finite so far?
Wait, why'd you put 5?
Because we have 5 terms. I'm just telling you as an example, if I wanted to find the summation of 5 terms.
Okay.
So n would be 5.
So we just plug in, right?
Yep, you plug it into your calculator.
So you don't have to do like the stuff before that, and then can you just plug in just from like looking at the equation?
Like if you're going from this equation and you're just like plugging in those numbers, that's fine. You can plug that straight into your calculator. Just be careful though. A lot of people make mistakes at this point where when they're plugging it into their calculator, make sure you use parentheses around everything in the top and then parentheses on everything in the bottom. Especially if you're using a TI-83, because otherwise it'll change your answer. Do y'all want to take a moment and plug that into your calculator and see if you can get the right answer?
Yeah.
Okay, take a second, plug that into your calculator. And I'm going to do the same thing because I don't know this off the top of my head. I mean, I do, but I don't. Okay, so what did y'all end up getting?
I'm still plugging it in.
You're fine.
Was that 121?
Yep. So I got 121. So the summation of the first 5 terms would be 121. Okay? So again, just plugging it in and making sure that you plug it into your calculator correctly. Okay? So for infinite, that means that I have a starting term, which is this a sub 1 right here. And then I've got, it goes on forever, right? Okay, so as a starting point, but it goes to infinity and beyond. So you're going to use the infinite formula, okay? And the infinite formula is this little guy over here, okay? So we're going to plug in a sub 1 is 1, and then we have 1 minus, well, now we've got to figure out what our r is. So we're going to take the second term and divide it by the first term, right? And this really should be 9 plus 27. I'm sorry. So we're going to take the second term and divide it by the first term. So what's 3 divided by 1? 3. So my r is going to be 3. So what I want you to do is take a moment and plug this into your calculator and tell me what you get. And remember, you're going to use parentheses in the top, and then you're going to use parentheses in the bottom.
Negative 0.5.
Yep, so negative 1/2 or negative 0.5, whichever one you want to say. So that would be the summation of where it would get to, right? Does not seem right. That's okay. All right. So why is that? Nope, that's right. Okay, so let's go ahead and look at some examples, okay? So down here at the bottom, yes. This is not right. Can somebody look on their formula sheet and tell me what the formula is? Because I don't think this one's right.
For finite?
Yeah, there should be a formula for
finite.
infinite.
It's Sn equals A1 parentheses 1 minus R to the n power and then divided by 1 minus R.
So that's the finite one, the infinite one. Yeah. Okay, so it's giving us negative 0.5. That's okay. This is a weird series. You normally wouldn't have this happen, but that's okay. All right, so now what we're going to do is we're going to look at some example problems, okay? So down here at the bottom, okay, I want you to write this probably on your piece of paper. I'm just going to give you some time to practice this. We're not going to do all of them. I just want to get a couple in here, okay? So on number 11, it has 4 negative 16, 64, negative 256. And it tells us that n is going to be 8. So that means that we're going to find the first 8 terms summation. Okay? My question to you, is this finite or is this infinite? Is it finite or is it infinite? And why? It's okay to be wrong, right? We can talk about it. Don't worry.
Infinite?
Okay, why do you say it's infinite though?
Because the ...
I think
Okay,
it's
so
finite.
there's this ... at the end. However, it tells us that it wants us to find the first 8 terms.
Yep.
So that has a
Like
starting
divide,
point and
right?
ending point, right?
Oh, so it's finite.
So it's going to be finite. So we're going to use that finite formula up at the top. Okay?
Okay.
So what I want you to do is go ahead and plug in to this formula right here. And what's going to be our R in this case?
4.
4 is the ratio, right?
So we're multiplying by 4. Now, is it
But
a
don't you
positive
divide,
4?
though?
What do you mean by divide?
It's a negative 4.
Wait, hold on.
Yes.
Okay, so some of y'all are saying that it's going to be a negative 4, so you have to take the second term and divide it by the first term.
Yeah.
So negative 16 divided by 4. Well, what's negative 16 divided by 4?
Negative 4.
Negative 4.
Right. So our ratio is going to be negative 4, right?
Mhm.
Okay.
Okay.
Wait,
so go
Miss
ahead.
Emmons, I have a question.
Yeah, what's up?
So isn't it finite where it's like an asymptote, it's almost touching a number, but it never touches? Or is that infinite?
That would be infinite. You're talking about like it goes on forever and it keeps going. Right?
Yeah.
Yeah, that would be
Miss-
an infinite.
Miss Emmons,
Yes, ma'am.
for the problem, would you put negative 4 or just put the minus 4?
Put the negative 4.
Okay.
Yep. Okay, so take a moment, go ahead and plug in 4 for a sub 1 and plug in negative 4 for r in both instances. And what is n going to be?
8.
8.
8.
Okay, and we got that from this n equals 8, right?
Yes.
Mm-hmm.
Okay, so go ahead and substitute all of that in. And I'm sorry if you hear that squeaker in the background. That's my dog.
I was just about to say, who has a hamster?
He was like, yeah, it's time to play. He's adorable. It's fine. Every time I get on like some kind of Google Meet, he comes in and just like messes it up. I'm like, stop. People are going to think I'm nuts. So,
Miss Emmons, you drink like 40 energy drinks a day.
right? Exactly. Here we are.
The first term is 4, positive 4, right?
So watch how I substitute this in because it's a little tricky. So we've already said that r is going to be negative 4. So a sub 1 is going to be 4. And r is going to be negative 4. Do you see how I use that parentheses?
Oh.
Does that help?
Okay.
Yeah, so it doesn't just go away. You're actually taking negative 4 and raising it to the 8th power. Okay, and then down in the bottom, it'll look like that. That is all kinds of ugly. I'm going to move this over here. I put too many things on here. I apologize. All right, so go ahead and take a moment and plug this into your calculator. Remember, when you plug this into your calculator, you've got to make sure that you use parentheses on everything in the top and then everything in the bottom. And yes, I meant to put that many parentheses there. Okay. So take a moment and plug that in, and I'm going to get this squeaker toy away from my dog.
Hey, he's not playing with that toy.
Right? play with me. Okay. He was not happy. Okay, so you're plugging that into your calculator.
24.
Hold on 1 second.
Oh, parentheses. Dang it. Oh, gosh.
Okay, so y'all ready for answer?
Yes.
Yeah.
Okay, so I got negative 52,428.
What?
Yeah. That's what I got.
Let me plug it in.
I got 24.
So let me ask you, Otis, with that, did you use all of those parentheses? Like, did you use like every single one of those parentheses when you typed it in? And on that bottom, make sure that you put minus -4 and don't hit minus minus, because that does kind of change it.
Okay.
And I'll retype it just to make sure I didn't mess up. Again, if
I press enter. What'd you get again?
at -52,428.
Okay, I got it now. Okay.
Okay. So Otis, check and see how you typed it in. And I'm gonna take a picture of how I typed it in my TI-83 so you can see that.
Oh yeah, I'm gonna do that.
Yeah. Did y'all all download that TI-83?
Yeah, I just
Yeah, it's on
forgot.
my phone. It's on my phone.
Good. Okay.
Miss Emmons?
So yeah.
Can you explain how you know it's finite or like infinite?
Okay, so can somebody tell me how I know that it's finite or infinite?
I'm not gonna do
Everybody's like flipping pages.
that.
So the reason why this one was finite is because that n equals 8, right?
Mm-hmm.
Okay, so it said, hey, I want to find the first 8 terms, right?
Yeah.
Now, if it didn't have an n equals 8, or if it didn't, like it had those little dots at the very
It's the
end.
formula.
Say that again?
It's the formula. Like it says finite and it has formula on it.
Finite.
And it said if you're looking for numbers, like n equals whatever number, then that's finite.
So you have a starting value and then you have an ending value. Like I could find the 8th term in this series, right?
So n is not how many numbers you need to find.
N is the number of terms. So this is a term right here. That's a term right here. This is a term right here. This is a term right here. That's 64. This is right here, the 4th term. So we would go all the way up to 8. Yeah.
When I plugged it into my TI-83 calculator, it gave me a positive 52,420.
Make sure that you have that negative inside of that parentheses here for that -4.
Which one?
That does.
How's
That
the answer
negative right here.
2,000 and all that? Like put the parentheses where it needs to go.
Say that again. Was it Gabby?
How is the number -52,428? Like, what does that go to?
So basically what you're doing is you're taking these numbers all the way up to the 8th term and you're adding them together. Okay, let's try this really quick. I'm gonna erase this and I'm gonna show you.
Let me screenshot.
Okay, hold up.
All right, go ahead.
Remember, I will do like a lot. Like this is being recorded, so you can't go back and like see it.
Oh, okay.
Yeah. Did you get it?
On my laptop. So.
Yeah.
Yeah. Okay. So what I'm going to do is instead of it being n equals 8, I want to do n equals 4 right here. Okay. So what I'm going to do here is I'm going to plug into this finite formula right here. Okay. So 4 is going to be my a sub 1. R is still going to be -4, right? And we're going to raise it to the 4th power. Okay. And then we're going to divide it by 1 minus -4. I want you to take a moment and plug that in to your calculator.
So when you don't use parentheses, does it change the answer?
Yeah. When you plug it into a TI-83, yeah, you've got to use those parentheses. And even the red ones that I just added. I know that sounds crazy, but like, I mean, you could type it without it, but it is going to change your answer. And that's where most people make mistakes, is typing it in. All right, so once you type that into your calculator, you should get something like -204, right?
Mm-hmm.
You say that as if you did not get that. Okay, so if you type this in correctly, you're going to get negative 204, right? All right. Now, here's what I want you to do. I want you to take each of these terms, and I want you to add them all together. So basically, type this entire line right here into your calculator and tell me what you get.
You want parentheses?
You get 204.
You want parentheses? 255.
Somebody's asking a question about parentheses. Say it again.
You want parentheses on the outside of them, or just add them?
I just want you to add this entire line up, just like how it's written.
Okay.
Okay, so when you type this into your calculator, and I'm going to give you a second to type it.
For
Guess
You
what
get
number
the
you
same
get?
answer. The same thing.
You
But
get the
quicker.
same thing, okay? So this is just a little bit faster, especially when you have n is 18. Like, your girl's not going to add up numbers all the way, like 18 different terms. Like, I'm not going to do that.
But it's wrong. You just said it's wrong.
What do you mean it's wrong?
You said that answer is wrong.
What answer?
This right here, the 4 parentheses 1, you said that was wrong. You said if you typed it in wrong, you get that answer.
You should get negative 204 when you type it in. You should get negative 204. For n equals 4. Now for that n equals 8, that's a different answer.
Oh!
Yeah.
Oh, okay, I got
Yeah.
it. I got lost. I'm like, what?
Yeah. No, you're good.
What's he talking about?
I essentially changed the problem to show you that we could add all these numbers out, right?
Yeah.
Or we could use this formula, which is going to be super fast, right?
Yeah.
I mean, in some instances, like this instance, if I told you, hey, n equals 4, you'd probably just add this up, right? Like that would be quick and easy. But if it was n equals 18, like y'all are going to use the formula, right? Does that make sense?
Yes.
Yes.
That makes sense.
Okay. All right. So other thing I want to talk about is the sigma notation, because y'all get caught up in the sigma notation. So yeah, I know, right? The worst.
Yes,
That old white
sigma is
dude.
hard. The sigma, that was not hard. It depends on
That
which
old
one
white
it
dude
is,
explained it really good. I don't know.
Yes,
his
he
name.
didn't explain. That's why I didn't get it.
I don't
Okay,
understand her.
so here's what I'm going to do. Do you see how there's a m equals 1 down here? Right?
Yeah, and it says
Okay.
There's no equal sign.
it's the 8,
Oh, there is.
right? Yeah.
Okay, it says m equals 1, guys. Down at the bottom. All right? So if I plug 1 into this, okay, that's going to be 4 to the first power, right?
Mhm.
Okay, so that's going to be 4. So my first term in this series is going to be 4.
Okay.
Okay? Now, do you see this 8 up here at the top?
Yes.
That's how many.
That says, hey, stop at term 8.
Mm-hmm.
So this is basically like saying, like over here, you see how it's like n equals 8? That's the same thing that we're saying over here. We're saying, go to the 8th term.
So that's like automatically how many numbers you need to find, or it did.
As long as it starts with 1 down here. And I know that's a little weird, but it should start at 1. So if I go from term 1 and count all the way to 8, that's 8 terms, right?
Mm-hmm.
Okay. Now, you're going to see this as whatever number is up here. That's how many terms you're trying to find. Okay. That's really how you're going to see this for right now. But eventually, if you go on in your math career, they're going to change this number right down here. Yeah, I know. The math career.
Whoa.
They're going to change this number down here and they'll make it like 3 and they'll make this like 15. And so you're no longer finding 15 terms, you're actually finding 12.
What?
Oh,
Yeah, I know.
Wait,
So we're not
but-
getting there.
That's
I'm not
the
doing that.
original formula.
back it up just a little bit.
Okay, so
Oh, you subtract.
starting term,
Mm-hmm.
that would be 4 because I took 1 and I plugged it in, right?
Yes.
Okay, so what would be my second term? If I plugged in 2, what would I get?
16.
16.
16.
Okay, and if I plugged in 3, what would I get?
No, another big number.
Okay, so
20.
what are these numbers going up by then?
They're going up by 8.
4.
2 or
4?
4?
They're going up by a multiple of 4, right?
Multiples.
So if I were to plug into one of these formulas, which formula would I use up here?
The one that's on top.
The infinite.
Infinity.
So which one? The finite, which is in the blue up at the top, or the infinite, which is in the bottom?
Did you circle
Finite.
it?
'Cause there's
Whatever
8
equation
terms
you
of
use for the
something.
other, I don't. Oh,
Otis had it. What'd you say, Otis?
Finite, because you're only looking for 8
the one
terms.
on top, the one that's blue.
Exactly.
Yeah.
So we're gonna do the finite because you're only looking for 8 terms, right? It's got a stopping point.
Oh.
Yeah?
Oh. Yeah.
Does that make sense?
Yeah.
Okay. So I want you to take a moment and try to plug into this equation up at the top.
I'm the good.
I'm gonna get rid of it.
So your first term is 1, or is it 4?
The first term is 4.
Okay. And then the
So
Okay, so what we're doing right now is we're taking this equation down at the bottom, or this, and we're plugging into that finite formula up at the top. So our starting term would be 4. So our a sub 1 is going to be 4, and our r is going to be 4. Our n is going to be 8. Okay, and once you've plugged it all in, go ahead and try to plug it into your calculator.
it's just positive 4, right? No negatives, right?
No negative.
Okay. 4.
Wait, the rate is 4?
The rate is 4.
Okay.
How did we find the rate?
Because it's a multiple of 8. 4.
Okay, so when we plugged in 1 into our formula, we got 4. When we plugged in 2, we got 16. Well, what's 16 divided by 4? 4, right?
Yes.
Okay. So you always take the second term and divide it by the first term.
Okay.
Got it.
Did you get it? 87,380.
Hang on, I'm about to plug it in. Still writing it. Honestly, you're way too fast. Way too quick.
That old white dude in the
I have a
morning
question.
really did a good job. I don't know his name, so I'm gonna keep calling him old white dude.
That's okay.
I have a question, Miss Emmons.
Yeah.
So if you have a question with the I don't know what to call that. E. Like the question has that formula on there. You have to pick another formula to use to solve for that question.
Okay, say that.
You know the one where you put the 8 over the and m equals 1 and all that.
Yeah.
Okay, so if they give us that formula for a question, we have to choose. Is it positive 87? A finite or an infinite formula to solve?
You would use the finite one.
To fill in numbers.
Yep. And so you would tell me at the very end, you would tell me 87,380 because you would have plugged this into your calculator. Does that make sense? So you're using the finite formula because there's a number here, right?
Because it stops.
If it wasn't a number.
So let's talk about that. So if there wasn't a number, let's say that, for instance, there was this instead. What symbol is this up here?
Infinity.
Okay, so which formula do you think you're going to be using?
Infinity.
The infinite one, right? Which is
This, yeah, that one.
R. Okay. So what was our first term in this instance?
4.
Okay, how did we know it was 4?
This is the first number.
The first term is 4.
We take 1 and we plug it in, we get 4.
Oh, so
Yeah.
if it was m equals 2 and you plugged in, would the first term be 16?
Yes.
Yeah.
Miss Emmons,
Okay.
Yep.
Miss Emmons, it was
What's
a
up?
it was a problem, and you had to multiply the numbers to get the second with the second number, like the ratio.
Yeah.
It was one of those. I did one of those. I wasn't sure if I don't know.
So to get the next number here, if I have 4, 16, 64, how'd I go from 4 to 16? How'd I go from 4 to 16?
You gotta plug it in.
I'm
Plug
multiplying
into
by
it.
4.
They're going to multiply by 4 and multiply 4 again.
Yes, which is exactly what this problem is doing right here.
You're just doing the square root.
You're doing the the cube, the square, and then the cube, and then to the fourth power, right?
That's
Yeah.
Now, if I were to find the summation of this infinite series, what I would do is I would plug in 4 for my initial, and then R would be 4, right? Because I saw that it's multiplied by 4 each time, so my R is going to be 4. So I'm going to take this, and I'm going to plug it into my calculator, and I'm going to simplify. And what is that going to give me?
4 over
4 over -3, or for those of you who like decimals, negative 1.3 repeating.
Yeah.
Right?
Mm-hmm.
Okay. Are we okay on this so far?
Yeah.
yeah.
Okay. So still want to continue that conversation of infinite. So I want to take a look at one of these problems. Okay. So what tells me that this is an infinite geometric series?
It keeps going on.
Yeah, it keeps going on, and it doesn't say anything about, hey, 8 terms, 2 terms, 14 terms. It doesn't have a stopping point, right?
Yeah.
Okay, so these are called ellipses down at the end. 1, 2, 3. Okay, those are ellipses, and that's our indication of, hey, it's going on forever, because there's nothing else that's written after it, right? There's no like n equals 8 after it. Okay. So this is infinite. So you're going to use the infinite formula. So take a moment. I want you to figure out what's your first term and what's your ratio, and plug it in. Okay. So you're taking question 31. I want you to plug in what's your first term, find out what your ratio is, and be careful of your negatives and positives, y'all. And then simplify.
Isn't your first time 1?
Yeah.
Okay.
How am I going to find my ratio?
It goes up by divided. Multiply. Over again.
Okay. So we're going to take the second term and divide it by the first term, right?
Yeah.
Okay. So in order to find my ratio, we're going to take the second term, which is -1/4, and divide it by the first term, which is 1. What's -1/4 divided by 1?
-4.
-1/4.
-1/4. So I'm going to plug that in for R.
That was, I don't know what he was doing.
And then now I want to plug this into my calculator.
Wait, what?
All right. So what'd you get?
1.3 repeating.
Couldn't you have just plugged in the second number?
Say it again.
Couldn't you have like just plugged in like -1/4 the second number?
Yeah, you can do it that way.
Sometimes we'll like that.
Sometimes it's really easy to see it, and then sometimes you're going to have to kind of do some finessing. So like in 32 right here, I mean, you can't see, I mean, you can see what the ratio is, but I would just get in the habit of trying to figure out the ratio like this. So taking the second term and dividing it by the first term. Right?
Yeah.
Right? So when you plug this into your calculator over here, what did you get? Haven't done it yet?
Hold on, I'm having difficulties plugging it in.
I was trying to figure out an easier way.
Well, we know that negative and a negative right next to each other makes a positive, right?
Yeah.
And y'all don't like fractions. Well, what's 1/4 of a decimal?
Oh, something.
0.25.
0.25. Okay, so doesn't this make it a little bit easier to type in?
Yeah.
Okay, so type that into your calculator.
So on the quiz, we can turn it into a decimal, and it won't change the answer.
It's probably better if we do it. But
Wait, why is it 1 divided by 1 plus 25 now?
So we said that since there's a negative and a negative, some people are having trouble plugging it in. So that'll make that a positive, and we know that 1/4 is 0.25 in decimal form. You should only have fractions, I think, but let me go back and check that. Worst case scenario, if you want to change it from a fraction to a decimal, or if you want to change a decimal to a fraction, just hit math frac on your TI-83 calculator, and that'll change that from a decimal to a fraction.
Okay.
All right.
Where's the math button? Oh, math.
Math is on the left-hand side. So if you typed into your calculator 0.25 and hit enter, hit math, and then hit enter again because it's the first option, it gives you 1/4.
Okay. Yeah, thank you, because I didn't know how to do that.
And if you ever want to change it from a decimal to a let me try that again. If you ever want to change it from a fraction to a decimal, you can hit math and then scroll down to where it says decimal. And boom, there it is. Okay. Are we okay on this?
Yeah, it seems pretty easy.
great.
Yes.
I'm gonna go back and watch it.
Okay.
Plus, yeah, if you get confused during the test, just watch the video.
Exactly. All right. So let's go ahead and move on to the next part. I know this is where a lot of people are having trouble.
May I get in a little?
How
Do you hear me,
though?
Taylor?
What's up?
Okay, Taylor, please. So I looked on the quiz, and the quiz has the sigma notation with m equals 1 to whatever number or to infinity, okay? And what comes after the sigma notation is actually a, the first term, times r to the power of k minus 1. So in this context, for all these beautiful minds here and actually super minds, I noticed here, would you please, you do have the PDF file from Mr. Jones, yes?
Yeah.
Okay, look a little at 29. If you look at example 29, that's sigma starting at 1, ending at 8, and actually is 4 to the power of m minus 1. So this is an excellent point to discuss how do you see the a when you have 4 to the power of m minus 1? And actually, all the problems on the quiz are with a number, parentheses, the ratio, another number to the power of k minus 1. So it is given to them. The question is if it's nothing in front of that number to the power of k minus 1, what's the a, which is 1. But the example you showed here with 4 to the power of m actually is 4 times 4 to the power of m minus 1 to follow the, you know, the format of the sigma notation. I'm just saying because all the problems on the quiz are on the as the notation on the PDF, and that sigma of 4 to the power of m kind of throws them, you know, of the, how are they reading this now, you see? 4 and 1/2.
So what she's talking about is the fact that if you were to be given this, you would, to find the first term, you would plug in 1, right? Just like what I said a second ago. And that would give you 4 times 1/2 raised to the 0 power, right?
Which is
Well, 1/2 to the 0 power gives you 1, and 4 times 1 gives you 4, right? So your initial term would be 4, right? Okay. In order to find your second term, you would plug in 2, right?
Yeah.
Y'all with me on this one?
Yeah.
Okay. So all I've done so far is I've plugged in 1, okay? And that gives me my initial term, okay? If I plugged in 2, let's say I plugged in n equals 2 into this equation, okay? I would get 4 times 1/2 raised to the 2 minus 1, right? Well, what's 2 minus 1?
1.
Okay, so I've got 4 times 1/2 raised to the first power. Well, what's 1/2 to the first power? 1/2.
Uh,
What's 4 times 1/2? What's 1/2 of 4?
2.
2.
2.
Okay, so your second term is going to be 2. Okay, from your second term, we're going to represent that by a ace of 2. In order to figure out your ratio, you would take your second term and divide it by your first term, right? So 2 divided by 4. 2 divided by 4 is going to give you what? 1/2. Do you notice how your first term right here, it's right here. It's chilling outside. And then you've also got your rate, which is right here.
Yeah.
Okay, so sometimes you can just look at the problem and your rate's going to be right here. And your initial normally is going to be right here. Just be careful though. There are some instances where depending on what's up here in the exponent, that can change. So just keep that in mind. Okay?
Yeah.
Are there any questions on that?
So the K minus 1. So okay, you plug in 1, right, for the K? What is it?
Yeah, it's n equals 1 and n minus 1. They are not different letters. It's n and 1 for K. K and K. Yeah, that's it.
Okay. Oh, okay. All right.
Yeah, that's it. Yeah.
Okay? All right, so it's just like what we just did. So, all right, let's go ahead and look at experiment, observation, and surveys. So, just kind of like a little quick overview. The difference, if y'all do me a favor and mute yourself unless you're asking a question, because otherwise I get kind of like back noise. So experiment versus observation. So an experiment imposes a treatment, okay, on individuals to collect data on their response to treatment. An observation observes individuals and measures variables without controlling the individual or their environment in any way. Okay, so experiment is, hey, we're going to do this treatment, or we're going to collect this data based off of this treatment. Observation is, hey, I'm just going to observe your decision making. Okay. Somebody asked about surveys. Surveys just ask a question or an opinion. So what's the difference between an observational study and a survey? Surveys are not comparative. Surveys draw data from only one group. So surveys cannot make conclusions about cause and effect. It's possible to give the same survey or to 2 or more groups and compare the results, but that is a type of observational study. Okay, so you can give a survey to a group of people if you want to give them to 2 different groups and then observe. Normally this doesn't happen, but it can. So examples, we're going to work through these. And on your quiz, you're actually going to have you're going to have the question, hey, is this a survey, observation, or experiment? Okay, and so you got to tell which one it is. And you don't have to explain why, but you should have some kind of backing behind that. Okay, all right, so in this first example, it says a researcher asked the students the average number of hours of sleep they get per night and examines whether the amount of sleep affects the student's grade. I should say grade. Okay, so I want you to take a moment, think about that one. Is that an observation, experiment, or survey? So a researcher asked students the average number of hours of sleep they get per night and examines whether the amount of sleep affects students' grades.
Observation.
What's the observation?
Okay, so why are y'all saying it's an observation?
Because he wants to see.
They're trying to find the outcome of them having sleep or not.
Exactly. So we're trying to find the outcome, and we're just saying, hey, how much did you sleep, right? Okay. Any questions over that one?
No, it's easy.
No.
Okay. A park employee wants to know if the latex paint is more durable than non-latex paint. She paints 50 benches with latex paint and 50 with non-latex paint. The employees apply a treatment to some of the individuals. So is this an observation, experiment, or survey?
Experiment.
Okay, so why are y'all saying it's an experiment?
Because the experimenting which one is better.
Treatment. They're trying to.
Like he's actually doing it.
Yeah.
Okay, so in experiments, normally what you do is you put them into two different groups, and you have a control and another one. Okay, so you have the bench with latex and the bench with not latex, right? And so you're trying to see the difference between those two. Okay, good job. All right, so on the next one, what is the best way to answer the question? Does listening to an MP3 player with earphones for more than 1 hour per day affect a person's hearing? Could this treatment harm a participant?
It could.
It could. Okay. So which type would you use? And this is kind of a more challenging question than you're going to get on the quiz. I just kind of want to take it a little bit further. But which would you use to make it the most ethical? And what does the word ethical mean? I know we talked about it the other day.
Safe. I don't know.
Safe and not judged by people.
So ethical means kind of good or bad. It's doing the moral thing, right? Okay. So what would be the most ethical way to do this? So if you're trying to determine whether or not it's going to affect a person's hearing, what would be the most ethical way to do this?
Observation.
Observation. Okay, why do you say it's an observation? Would be the most ethical way.
The way I'm doing it is you get people, it's like, how do I explain it? It's people that are already doing this, so it's not your fault if they damage their hearing.
Right. Yes. Okay. So an observation would be the best way to do this, because if you were to do an experiment, that means that you're telling people, hey, listen to really loud music for an hour. Well, that could potentially make them deaf. And that's not an okay thing, right? Okay, so
butt is getting sued.
yeah, right. And a lot of people like who do experiments, they've got to be careful about that. Okay. All right. So this last one, it says, Coach Emmons wanted to know how many students log into other teachers' Google Meets. So Coach Emmons sent out a remind message and said, like this message if you logged on today during the Google Meet session. Is this an observation, experiment, or survey?
Survey.
Okay. Why is it a survey?
Because you're asking them, like you're asking them the question.
Okay. Exactly. Is that Ethan?
Yeah. Hey, Coach.
Hey. All right. So that would be a survey because I'm asking people, hey, did you do this? Right? What's up, baby?
I still don't understand the difference between a survey and the observation because they both sound the same to me.
Okay, so a survey, you're basically going to say, how do you feel about this? And it's kind of like either a piece of paper or they have to check a box and say, oh, you know, I want to do this. Observation is I'm standing back and just observing whether or not you make that decision. I have no influence. I don't really have an interaction with you. Observing it. Say that again.
You're trying to see if it happens or not, or
right. So like for instance, for an observation that I would have, let's say we were having a banquet and I put out Sprite, Coke, and Mountain Dew. And I wanted to figure out, you know, how many of my kids like Sprite, you know? So I would just observe based off of that. And I would make my conclusion based off of how many people pulled a Sprite.
Or you can do a survey.
So a survey is just asking a question, and then observation is just looking, observing.
Yeah.
Usually, most of the time.
I mean, normally what you're going to see is the survey is going to say some type of question. It's going to say,
yes or no.
Yeah, it's kind of like, what's your opinion of this? Yeah.
Okay.
And there are some Khan Academy videos that are online that go over surveys and observation experiments. And if you want to practice some, I think he's got some as well posted on there. So if you want to go to Khan Academy, and Khan is Khan, I think he does have some practice problems on there. And if you still can't find them, let me know. Okay.
Yeah.
And then somebody wanted me to go back over this problem from Tuesday. I know some people were having issues on this. Yeah. So the answer key was posted, but I want to make sure that we understand what it means. So it says, consider the picture below consisting of nested sequence of 5 equilateral triangles colored in black. Each of the black triangles is made up by connecting 3 midpoints on the sides, blah, 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 blah. Find and evaluate a sum to compute the total area of the black region. Oh, this is from Monday. I'm sorry. Okay. So this is talking about infinite and finite series. Okay, so my question to you, is this infinite or finite? Like, is this problem, is this triangle finite or infinite?
Finite.
And why?
Finite?
Finite?
My question is, does it go on forever?
No.
No. It stops at a certain point. There's boundaries on this, right?
Yeah.
So this is obviously going to be that finite concept, right? Okay. And so then they start talking about, they want you to evaluate a sum to compute the total area of the black region, right? Find and evaluate a sum. Okay. So when we look at this big triangle, and this is going to take some visual, okay? When I look at this big triangle, how many other triangles is it broken into? What's the next size down amount of triangles? Well, there's 1, there's 2, there's 3, and then there's this big black triangle right here, right? So how many triangles were there that are red or one of the blacks? There's 4, right?
4.
Okay. So out of those 4, how many were black?
1.
1.
1.
Yeah.
Yeah.
Okay.
One is all black.
1 is all black, and then the 4 are in those red, right?
Mm-hmm.
Okay, so that's kind of like our initial term right there. Okay? With me so far?
You said 1? I'm confused.
So this one right here,
Come on, the
this
big.
is the one black triangle, right?
Yeah.
And then everything else is just like a regular triangle. We're ignoring all these little triangles right now.
Okay.
Okay, with me?
Yes.
All right, let's talk about the next size down. Okay, so the next size down is this triangle right here, right?
Mm-hmm.
How many triangles are just a little bit smaller, the next size down triangles? How many are there? Well, let's look at it. Well, there's 1, 2, 3, and then you got this black one right here, right? So how many total triangles are there?
4.
4 in that little section, right? And how many are black?
1.
1. Okay. Well, what level did we go down to? We went to the second level, right? Like we went one size down, right? So we're going to raise that to the second power. Does that make sense?
Why?
We're going 1/4 more down than the 1/4 that we already had. It's kind of like taking, you ever taken a piece of paper and folded it into fourths, right?
Yes.
And then you folded that again, right?
Yeah.
Right? So you take a piece of paper, you fold it into fourths, and then you fold it into fourths again. How many? I'm sorry. I think I'm missing this. 1, 2, 3, 4. 2. Missing that one. There we go. How many boxes will there be once you fold it again? Count those boxes up.
16.
Okay. So this is 1/16. Do you see that 4 squared right here?
Yes.
There's 16. Okay, so if we count the number of triangles, not including this stuff right here, let's count the triangles. We've got 1, 2, 3, 4, 5, 6, 7, 8, right?
Yes.
Okay, and then we're having that second level down. So that's why we're squaring this right here. And I know this is really hard to see or conceptualize. So we went from the big triangle to the next size down, right?
Okay.
Okay. So then if we repeated that process, let's repeat that process. So let's go to the next size down, this right here. How many triangles do we have in that one triangle?
2.
The next size down. Nope. The next size down from there.
Oh,
That would be
4.
4. And how many of those are black?
1.
1.
Okay. And what level are we on?
3.
3.
Okay. Let's go to the next size down, right? And this gets really hard to draw on.
4, 1, 4.
Okay. So Otis has already gotten this down. 1, 4, and raised to the 4th power. Okay. And then we've got one more down, right? Sorry.
Yep.
We've got one more down because we have 5 black triangles, right?
Mm-hmm.
So we've got 1 over 4 to the 5th power.
Yep.
This is what your answer key says. Okay. And when you added it all up and you put it into your graphing calculator, it told you it was like, I don't remember off the top of my head. I think it was like 310 over 2 something. I don't remember what the answer actually was. But, and we can plug it into our calculator. Or I don't want to do all of this extra work, right? Like I don't want to do that work. So why don't we use that finite formula? Let's do that because your girl was not liking this. And I know some of y'all are like, I don't even know what just happened. Okay, so let's think about it. This is our finite formula. Well, what's our initial term? What was our first term?
1/4.
1/4.
1/4.
Okay. And then what was our R? What did we keep repeat? What's repeating in here?
1/4.
1/4. Okay. And how many black triangles do we have in total? 1, 2, 3, 4, 5.
Okay.
So my n is going to be 5, right?
Mm-hmm.
Over 1 minus 1/4. Okay. If we plug this into our calculator, we're going to get the same thing as what we would have gotten if we added all of this up.
Are you counting the big triangle too? For 5 triangles?
No, for 5, I'm counting the black triangles. So I got 1, 2, 3, 4, 5. Little baby one up there. 1, 2, 3, 4, 5. Right?
Oh wow. Okay.
I can still count, right? I think.
Yes.
Okay. All right. Listen, this quarantine has been making me crazy. All right. So if I plug this into my calculator, and I want you to take a moment and try to plug it into yours as well, because that's a little tricky. So just be mindful of your parentheses. And if it says 1/4, just type 0.25 if you don't like it. Take a moment, plug it in, because you know that's where you mess up. No offense. All right. So when you do that, you should get 341 over 1024. Or you got a decimal that's like 0.33, blah, 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 blah. Again, remember, if you ever get a decimal and it's given in fraction form, remember, hit math, then frac on your TI-83. And I think Desmos also does that, but I haven't figured out how to do it yet.
Will that be on the quiz?
Oh, no.
Okay.
This is going over right now.
No. Somebody just asked, hey, how do you do this?
Thank God.
0.25.
I feel that.
0.25 or no?
What? For 1/4, you could do 0.25.
Yeah, I'm asking, is that the answer I'm supposed to be getting right now?
No, you should be getting this.
Oh, but that. So, what am I getting?
Here, I'll take a screenshot of my calculator. So it looks like this when you plug it into the calculator. So I typed all of that mess in the blue up at the top, and then I hit math frac, and then got that.
Oh, I forgot to do the 5.
Don't forget the 5. That's important.
Man, I didn't see that.
You done messed up, Aaron. Yeah. All right. Are there any? I'm gonna go to the next page. Is that okay?
This recorded, right? Okay.
Yeah. Okay, so anything else? Just for my kiddos, I have updated your digital learning day 1 and 2 in the grade book. And I'm currently going back and looking at your AKS 16 and 17 and 33 for Delta Math. I know some of y'all finished that up over spring break. If you're missing anything from the past like 2 weeks, go ahead and take care of it. I did put in NTIs if you didn't turn anything in. Like I can't grade it if it's not to me. Okay, so keep that in mind. Obviously, like, get it to me as quickly as you can. What's up?
Explain the extra credit project?
Yeah, I can explain that. What was the other question?
Miss Emmons?
Yeah.
What if for one of the Delta Maths, you only did half of the section?
Yeah, can you
I gotta, it was just so hard.
Do I need to reopen that?
Please.
Which one was it?
But like, I need
the let me see. The one that you extended. I don't know.
Okay, so I'm gonna reopen those. Sorry, that was not what I wanted to do. I'm gonna reopen those, and I'll let you know when I open them. I'm probably not gonna do it until Monday though, just because I'm trying to finish those up first.
That's great.
So just focus on your midterm and your other stuff, and then we'll get there. So
yeah, 16, 17, the AKS, so that one.
Gotcha. Okay, and if y'all are struggling on that, again, just make sure that you like send me a screenshot of it, and we can talk through it, or we can do a Google Meets on it. So for the extra credit project, let me pull that up. I know.
Is it a group project?
No, it's an individual.
So can it
say again?
So like the project, like around the house, like I'm confused, like how I could put the project together.
Okay. So let me pull up the actual document so I'm looking at the same thing. There it is. Okay, well I guess we're not gonna work. Yes. Don't you love technology? It's so good.
No, it's complicated.
And you don't use the AKSs for this semester?
Yeah. So this is supposed to help your summative grades for this semester. I don't want you to do last semester because last semester is already done. So we like that sometimes. So let's take a look at the project. And this is on eClass. I know some people complain about not being able to open it on their phone. It is a Word doc, so if you don't have Word downloaded on your phone, can't see it. Hashtag Android. Okay, so the extra credit project. So your job's come up with a project around your household. This can be a chore. Like my mom used to make me like clean baseboards with like a wash rag. Like that's what my mom used to do. And so like I would want to figure out like how long is that going to take me, right? And that's creating an equation which is AKS 16 and 17. Okay, so I would write out, hey, it takes me 2 hours to clean, 3 rooms or whatever. And I've got 9 rooms in the house. And, how long is it going to take me? And can I make my movie at 6 p.m. or whatever? I mean, you can create a for instance, and that's fine. And somebody asked, do I have to create a video or can I do it on paper? You can totally do it on paper. That's fine. You just need to write out like what your plan is, how you figured it out. Like there should be some type of math.
I would like acting on the video, like fake cleaning. I don't know who wants to do.
Say that again?
You said make a video, like make a video of us cleaning?
Sure. I mean, I like, so my example right here, that's the garden example. Like if I were to make a video of this or vlog about it, I would probably, show, hey, this is my strategy. And so I would probably show a piece of paper that has all of my work written out. And then, I would say, hey, this is the amount of space that I have, and maybe video the project that I was setting up. Like I would go take a picture of my garden, or I would video my garden, be like, this is how it looks at the end of this. I'm just kind of wanting y'all to be creative, and I want y'all to get off the computer. I'm not even gonna lie. Like I know y'all are so tired of being caught up on all of this. So
go on runs.
How about we turn it in? Like you want pictures? I don't know how to like set up the project. Like I don't know if you want it like on paper, you want it video. Like, I don't know.
You can do either. It doesn't matter. Like you can turn it in on paper, or you can do it on a video. That's
so how many problems do we need in total?
How is there what?
How many problems do you need in total? Like, how many problems do you want?
So depending on your AKS, because for instance, if I did AKS 16, which is creating an equation, that takes like 2 seconds to create an equation. So I would probably pair that with another AKS. Okay, so that I could hit another AKS to help that, right? However many AKS you do, this project grade goes to those summative grades. So if you want to do AKS 34 and AKS 16 and combine it somehow into this project, I'll go back and I'll replace those.
How
Does that make
Miss
sense?
Emmons, is this all?
What?
Are we done reviewing?
Say that again?
Are we done reviewing?
Yeah, we're done reviewing. So if you need to go, that's fine.
Okay. Peace.
No problem. What was the other question?
How well can this help your grade?
I mean, depending on what your grade is in the class. I was sitting there trying to play with the numbers the other day. If you're like at an A right now, it's probably only going to help you like 1 or 2 points. If you're at like a C, it could help you like 5 points depending on what AKS you do. And this is overall grade I'm talking. And then if you're like super failing, I mean, this could really help your grade because you can do more than one. Like if you want to do multiple AKS or if you want to do multiple mini projects, because I know it's kind of difficult to combine all of them. So if you want to do a graphing AKS project, and then you can do a creating equations project, that takes care of 2 AKS right there. And those are 2 little mini projects. They don't have to be super detailed. I'm just trying to get you to see the math that is around you. That's really what I'm trying to do.
So if you were to do this, how would you like do it? Like if you were to like type it out, something like that, or like do it like for real, like on video. I don't know how you would do it. So like, how would you do it?
So the first thing that I would do is I would start with my planning project or process page. Okay. And I would try to figure out which AKS do I need to focus on. Okay. So I would look at your grade book and say, hey, I sucked at AKS, whatever. I probably should do something on that. Okay. And then I would look at this planning process page. Can you see that?
Yes, I can see.
Okay. And so I would write down what AKS you have. Okay. And then I would probably ask my parents, hey, what kind of issue do we have around the house? Like, what can I help with? Or, ask your mom and dad or ask your whoever you live with, like, hey, what needs to be done around the house? Like, because normally that's going to give you some kind of like thought. So have you asked them yet?
I already know what to clean. I'm not going to ask, but I already know what to clean already.
Okay, so what I want you to do is think about some cleaning projects that they would ask you to do, okay? And see if you can relate that to the AKS. See if you can kind of like intertwine those. Does that make sense? That's how I would start this, okay? And then once you write out that planning process, like what resources you're gonna need, how would that help you in the household? Once you write all of that out, we can talk about like actually doing the project. But I want you to think about your planning process first. Start there. Does that help?
I'm just confused on how am I doing this project? Like, how am I doing it? Like, what?
Like you're recording from start to finish what you're doing. Like, hey, I'm going to go vacuum my house. This is how the math's related. And I would show the math. And then I would probably record me vacuuming for a little bit. I don't know. It depends on what AKS you want to start with. Like, go to your grade book and look at which AKS. And we can talk about this in just a second. I want to make sure that I hit all of the broad questions first. So, but we can talk about that in just a second. So stay on. I'm going to go ahead and hit stop recording really quick, just so we can actually like have conversation.